Hey kids, so we're gonna finally make another slide, I guess. Let's try that. We'll try this. All right. If you're following at home in a book, this is chapter 7. So this unit 6B, just gonna keep naming units something absurd until we're done, involves some more stuff with the mole, and one of the things it involves is what we call formula mass, and formula mass, as many of you were able to determine with the molecular models we were using, is the sum of all the atomic weights of the atoms in a molecule or formula unit. Molecules deal with covalent um, compounds, and formula unit deals with ionic, and we'll talk about that in a minute here. And there's your picture of formula going to mass. All right. So what is formula mass? So if you go to the periodic table, you will see that fluorine has a mass of 19.0 if we're going to take it to 3 decimal places. And since fluorine F2 has 2 molecules of fluorine, we need to multiply that by 2 to get a total mass of 38 grams per mole. The same can be said, I guess let's go here to C2H6O2, which has 2 carbons, 6 hydrogens, and 2 oxygens. So if we were going to sum all that up, we would have 12 is the mass of carbon, and there's 2 of them in this molecule, so that's 24. Hydrogen has a mass of 1, and there's 6 of them in this molecule, so that's a mass of 6. And then oxygen has a mass of 16, and there's 2 of them, so that's a total of 32. And then when you add 24 and 6 and 32, you get a total of 62 grams. All of these come from the periodic table. All of these come from the formula. And then aluminum sulfite, I think that is, 2 aluminums, each one weighs 27 on the periodic table, so that's 27 times 2 is 54. The sulfur, this 3 distributes, and I keep doing this. I don't know if it's at all helpful, but in case it is, I'll do it again. So if you have something like, if you have something like 3 times x plus 2, you distribute that 3 through the parentheses, so you get 3x plus 6, right? So the same thing is true with this parentheses here. You're going to distribute this 3 through that parentheses. So that's why the sulfur is now times 3 and the oxygen is now times 9. Each sulfur weighs 32.1, so that's 96.3 after it's multiplied by 3, and each oxygen is 16, which times 9 is 144. And then you're going to add these all up to get 294.3 grams is what that would weigh. All right, so that's formula mass, and you should be able to do those. And remember that the amount in each element is a mole. It's different weights, but the number of items is the same. And in this case, it's a mole. So 6.02 times 10 to the 23rd. And another thing, we did this with the formula unit. We tried to learn what a formula unit is. And I had these magnets, which were painted different colors. So the red was supposed to be the non-metal and the metallic was supposed to be the metal. And the fact that they stuck together means that if you had a bunch of them, they would form what we call a lattice, and it would just repeat over and over again. Since every green is attracted to a purple and every purple is attracted to a green, it's just going to keep on this pattern over and over again in all directions. So the formula unit is the smallest repeating pattern, and this is an atomic level situation. So the 2 atoms or 3 or 4 or whatever it is in a ionic compound that is repeating over and over again is going to be considered a formula unit. And then you all figured out quite nicely that these lend themselves to being solids because since they're stuck together, they don't really have the freedom of movement to be a liquid or a gas. And then we also play with molecules. Molecules, here's 2 methanes, and there was no stickiness. And because there is no stickiness, molecules, which is non-metal and non-metal, tend to make liquids and gases because there's not an attraction between them as much as there are for ionic compounds. And so the molecule was sort of this freestanding group of atoms that form the compound, but it just repeats over and over and over again. So here you can actually see water. So 2 hydrogens and an oxygen just repeating over and over and over again, which is different than the formula unit, which is just the same pattern that's stuck together over and over and again. And this is the smallest group of that. A molecule is sort of this freestanding thing. All right. So in summary, a molecule is covalent. So you have two nonmetals or multiple nonmetals coming together here. Carbon, oxygen, and hydrogen are forming ethanol. It's sort of a freestanding situation, whereas formula units are always ionic, where a metal and a nonmetal are attracting each other in a charged situation like magnets. And because of that, there's an ongoing pattern. And we're talking about the smallest unit of that. So whenever we're talking about molecules or formula units, we're talking about atomic level situations here. So we're going to need that 6.02 times 10 to the 23rd to figure out molecules or formula units. Molecules and formula units, just again to stress this atomic level of things, it takes 1 billion molecules to enter your nose before your nose even registers a smell. So if you have 1,000 or 1,000,000 molecules in your nose is still not going to register any smell. It needs 1 billion molecules in your nose before something starts smelling. And again, if you want to remember what a mole is, they say all the time, it's like a dozen. It's sort of a word that means a whole bunch of items. And if you have a case of soda, that's 24 bottles. And if you have a dozen eggs, that's 12 eggs. If you have a gross of something, that's 144. A ream of paper is 500 sheets, and a mole is this many items. And we need that number to use these small things and start making them worthwhile and noticeable. So here's some examples. If we have to convert 0.275 moles of HNO3 to grams, we're going to start with the 0.275 moles. And we need to go from moles to grams. And to do that, oops, didn't do a light blue for some reason. Let's go blue. All right, so we got to go to grams. To get grams of this compound, we're going to need to do the formula of mass. So hydrogen, nitrogen, and oxygen. There are, in each of those cases, there's one atom of hydrogen and its weight on the periodic table is 1. There's one atom of nitrogen, its weight on the periodic table is 14. And there's 3 atoms of oxygen and its weight on the periodic table is 16. So that comes out to be 48, and this is 14, and this is 1. And when you add up 14 and 48 and 1, you get 12, 13, 63 grams. So 63 goes there, and that is the grams, as we just talked about. Anything from the periodic table is the grams in 1 mole. So when we multiply 63 times 0.275, we get, I know it's so exciting to figure this out. There's my calculator. All right, I was about to say, I brought a calculator into the studio and I don't know where it went, but I got it now. 0.275 times 63 is 17.3. So that's 17.3 grams when you do that out. So that's how many grams are in 0.275 moles. And it makes sense that it should be less than 63, right? Because we don't even have 1 mole. So it should be less. All right. So the conversion highway for this, if you're just jumping around between grams and moles, you're only going to need to do one step, and that step is going to involve the periodic table. If, however, you need to involve formula units or molecules, if these very small atomic level things are involved, then you're going to need this number. But you're not going to need that 6.02 times 10 to the 23rd unless you see the word molecules, formula units, or if it's the midterm atoms involved. All right, so here is an example if we're looking at formula units of NaCl. So we have 5.98 times 10 to the 21 formula units of NaCl, and we need to go from formula units to moles. We know that the relationship of formula units to moles is that for every 1 mole, there are 6.02 times 10 to the 23rd formula units. All right, that's sort of the definition of a mole. So that gets rid of the formula units, and we have mole. And if we do that on my handy dandy calculator, we will get 21 divided by 6.02 to the 23rd is 0.00993. And that would be moles. So let me get back into red. So that equals 0.00993 moles. All right. So in this one, where you're going from grams to moles, I can't remember what color grams was, because I'm going to say it's blue. And we're going to molecules, right? So molecules is one of those really small things. So we're going to need this number again. So we're going to start with what's given, and that's the 9 point, oops, I thought that was blue. Actually, let me erase that. Let's erase it. All right. And I'm blue. So 9.24 grams. We got to go from grams, ideally all the way to molecules. I'm going to just go straight to moles here. Those of you who have figured out some other things, but that means gram to moles is a relationship on the periodic table. So I got to figure out what SO2 is. SO2 on the periodic table is going to be, so sulfur, there's one of those, and each one is 32. So that's 32. And oxygen, there's two of those, and that's 16. So that's 32 as well. And that's a grand total of 64 grams. So 64 grams is the number of grams in 1 mole of SO2. That's pretty good, but now I got to get out of moles and get to molecules. And in order to do that, I am going to again use that 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd molecules is the amount in 1 mole. And then we multiply all that stuff. So 9.24 times 6.02 times 10 to the 23rd. That gives us 5.56 times 10 to the 24th. So that's 5.6 times 10 to the 24th. And that's going to be divided by the 64 grams down on the bottom. And when you divide that by 64, you get 8.69 times 10 to the 22nd. So your answer in green is 8.69 times 10 to the 22nd. Yeesh. 10 to the 22nd molecules. All right, so that is the answer for that one. All right. And then I'm using a lot of these. I don't know why I'm doing this, because I keep telling you, in reality, you don't do much of this. So we just figured out 8.7 times 10 to the 27 molecules is how much? 9.24 grams. So this actually is just asking you to go backwards. And so that many molecules will weigh, if we figure out the mass of that, you should be able to go backwards on that and figure out that it is 9.24 grams. So that's what our answer should be. If we start then with the 8.7 times 10 to the 22nd molecules, and then we want to go from molecules to moles, and that's 1 mole is 6.02 times 10 to the 23rd molecules. So if you do this math backwards now, and then every 1 mole of SO2 weighs what we just did on the other page, and I think it was 64 grams. So if you do that, you'll get back to 9.24. All right, and that's all I'm going to talk about for this, and that is the first couple days of what we did.